Alright, all you lovely chaps out there. Do some stuff on cones today, but before we do, I want to get you a jump start on something else, a revisitation of sorts. So I'm going to create a sector right here. Alright, so imagine that this part is your little sector. Okay, and I want to find the area of the sector. Now the way that we used to do it, and the way that we still always should obviously, is we say, what fraction is this central angle out of the entire circle? And whatever that fraction is, we end up taking the same area in comparison. So let's say this fraction here, or let's say this degree was like 110 degrees. So we'd say, well, we set up a proportion. 110 degrees out of a total 360 is equivalent to the area of our sector out of the area of the entire circle, which I guess would be pi r squared if this was the radius of r. Okay. Now this type of proportion will have to make a lot of sense to you as you do this. Now from this point you normally cross multiply, or you find a way to reduce this, or whatever else. I want you to see this kind of in a different light. Let's just solve for x. Let's say x equals, to do that you have to multiply both sides by pi r squared. Pi r squared. So x would equal 110 over 360 times pi r squared. So you take that whole area here, multiply it by whatever fraction you're taking. Okay. Now we're going to do the same thing, only this time we're not going to use a central angle to solve it. We are going to look at the arc length instead. And so you know, it works the same way. If I figure out what the length of this arc is right here, like that, and I divide it by the length of the entire thing, the circumference of it, I get the same fraction. Because there was one time, and I only wrote it once, and so I would be completely surprised if you actually even remembered it. When we said that we had a central angle here, this has the same arc measure. So if this was 110 degrees, this arc measure is also 110 degrees, because this is 110 out of 360 in the circle as well. So you could set up the central angle thing that way as well. But let's say we just looked at the actual length of this thing. If this length was like 5, and the entire length, no, that wasn't even close, but if the entire circumference was, let's say, 20, then you do the same setup. You'd say, okay, 5 over 20 equals, and the same thing, if you want to find the area of the sector, it's still x over pi r squared. So, like 5 over 20, I guess, reduces to 1/4, so 1/4 equals x over pi r squared. And so multiply both sides by pi r squared, x equals 1/4 pi r squared. So when we're figuring these out, I mean, this is something I'm introducing before I get into the actual concept here, because we're going to talk about surface area of a cone. And this is going to be an important concept because cones will kind of look like this when we map out its lateral area. But just to get you a good understanding, because we're going to use different variables, we're not always going to use r for things, we're going to use slant height for some things as well. So I might refer back to this, but I wanted to get you a good start on that. Okay, the cone, besides the sphere, the cone is the most difficult visual representation as far as how to make sense of it. So I'll do the best I can, and you'll do the best to follow along as you do it as well. So cone is this guy right here. Okay, this one happens to be a happy birthday cone. And what I'm going to do with this eventually is lay it out flat. Okay, now imagine this also goes in the back like that. Alright, so we've seen cones before. They also have a certain height to them that looks like this. Well, that's not a line tool. Looks like this. Okay, the height goes right down into there. There's your height, and there's something called slant height as well, which we've talked about. So here's height. Your slant height is L. It's the distance from tip of the cone to anywhere along the rim. So notice the difference. Height goes straight down the middle, goes vertical and perpendicular to your base. Here's your base down here. It's perpendicular to it. Your slant height is the one that goes right down one of the edges. So this is also a slant height that goes all the way down to there, if that makes sense. This is all L, and this is all congruent the entire way around. Okay? So these are all slant height. Slant height also goes in the back. If you see this go into the back right there, that's all L, your slant height. And just like a pyramid, remember, as we've drawn pyramids before, okay, your slant height in a pyramid, there are only some specific ones. Slant height would, for instance, be right here. This guy right there, that's L. And this down here is L, etc. So these are your slant heights in a pyramid. But in a cone, they're always the same all the way around. It goes down every which way. Okay. Now here's going to be the tricky part. What I'm going to do is unfold this cone, and literally I'm just going to go to the next slide, and it's a picture of this cone unfolded. So here's what you're going to have to practice drawing as far as a net. They won't always be the same, but they have the same idea. And they always look like the sector of a circle. So check this out. So this cone is now unfolded. And what we had before here, I mean, I could show you the actual cone, but this slit goes right into there, and it forms together, and then it makes that part right there. You can see the happy birthday thing. I'll go back again. Here's happy birthday right here. I take the cone by one part, and I unfold it completely, and it gets this. This doesn't end up looking perfect, but what you have here is this. These two lines still represent your slant height. I take this part and I unfold it, and this is the length of slant height, L. So this is L, and this is L. And so are these guys, by the way. This is also L, 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 etc. So this is the same distance the entire way through. Meanwhile, what you have over here is the portion of a circle. Okay, so this part's curved the entire way around. So this is not straight. And if I were to complete this, it won't be a perfect drawing at all. But if I were to complete this, pretend like this was just, well, I'll try it one more time actually. Going through around here. Then it goes up and around and through and back down. So this is kind of, you're looking at it at a tilt right here, but this is a circle where this is the center, and it has a radius of L right here. Instead of a radius of R, this is a radius of L. So let me go back to that other sector one before. It's the same thing like this. Here's something where we have a slant height of L. It's the same as your radius, just like that. And here's the full circle. The rest we can't see. But this is the party hat unfolded. Okay, so there's the unfolded party hat. Here's the remainder of the circle right here. So now, I'm going to go and draw this green now. I want to find out what this distance is here. So let's go back and let's look at this circle before we unfold it, this cone before we unfolded it. Now, if you look at the green down here, okay, this whole thing unfolds. Remember, there is information in the back. This whole cone goes all the way around. If I could rotate it for you, I would. But if we take this at one point, like say like right here, and we unfold the whole cone, that circular part is this bottom portion right here. So as I go from here all the way around to here, that is the same distance as this right there, this green. So this distance is the same thing as the circumference of the base. Okay? Keep in mind, this bottom portion is a circle. This bottom portion is a base. Now, in a party hat, there's nothing solid there. When we talk about cones, though, we will say that there's a solid base. So when I draw actual surface area, and when we start looking at the actual notes, you'll see that there's a circular base that we need to include area of as well. But when I unfold this, this has a radius of L, like this, that's slant height. But when this unfolds, this part right here becomes the circumference of your base. So if we are looking at cones in this fashion where we call this part R right here, because this is the original radius of the circle of your base, this right here, this R, doesn't really make sense in the sense when we unfold this. Like I can't see an R right here because we haven't unfolded the base, but the circumference of this base right here equals 2 pi r, right? The circumference of any base is 2 times pi times its radius. So this distance right here is 2 pi r. So going back here, this distance from here all the way over here is 2 pi r. Okay? You can see why this is very confusing, and I'm not even done making this confusing. But that's why I'm kind of going through this one really slowly. This one's going to be the most difficult one to get a visual understanding of. I said besides spheres. Spheres I can't even really explain to you. I can a little bit, but it's going to be near impossible. But as for the cone, here's your lateral area. So it involves this radius here, L, and this circumference, 2 pi r. Now this circumference, 2 pi r, isn't the circumference of the circle. In fact, I want you to think for 1 second. I'm going to pause for about 10 seconds as I want you to think of how I find the circumference of the entire circle here, including, party hat and non-party hat. This blue with this green. What's the circumference of the entire thing? I'm going to pause for 10 seconds here without talking and see if you can think about it. Okay, I'm back. Let's see if you thought about it. This circle has a center right here and a radius of L. Okay, this time the radius is an R, but the circumference of this entire circle, it's not a very good color. Let's keep using blue. Circumference of that entire circle equals 2 pi radius. Your radius is now L in this circle here. Okay? See if that makes sense. It's not 2 pi r anymore. This doesn't have a radius of r. It has a radius of L. Now we're going to use actual numbers when you solve for things. So this radius might be 6, for instance. You do 2 times pi times 6. So the question is, okay, I want to find the surface area of the cone. And in this case, let's just do party hat. I'm going to talk about the base later when I add into it. But I want to find this area here. The area of a sector of a circle. How do I find it? This is where I go back to what I was talking about before. We did areas of sectors before by taking central angle out of entire circle. Well, you can do the same thing by finding the length of this part, this arc length, out of the entire circle's length. So if I know the length of this right here, like 5, and the length of the entire thing, like 20, then I do 5 over 20. I set up that proportion, and that proportion will be the equivalent to whatever proportion we have here for area as well. So this area here over the area of the entire thing. So let's set up a proportion based on what we know. If I take this length right here and divide it by the length of the entire circle, then that same proportion will give me this area out of the area of the entire circle. So let's set up a proportion here. What's the length of this green line right here? This length is 2 pi r. Right? And this is where it gets confusing because you know 2 pi r is circumference because you say that all the time. But this r is not the radius of the circle. No, it's the radius of the circle of the base of the cone. And that's something we still haven't even drawn here as the net yet. That's why, like I said, this is going to take a while to get. But this was the radius of this circle right here. When we unfolded it, that circumference of that base of the circle ended up just being this length right here. And here's an imaginary circle right here, circumference. But so what I'm going to do is take this length, this green, 2 pi r, and divide it by the circumference, the length of the entire circle right here. And that circumference was 2 pi l, 2 pi times the slant height. Or in this case, the radius of this bigger circle. So here's a proportion right here. And that will be equal to the area of my sector, the unknown I'm trying to solve for, over the area of the entire circle. So, what is the area of this entire circle? What's the area of any circle? Area of any circle, as you would say, is pi r squared. But r would be your radius. In this case, our radius is L. So our radius this time is pi L squared. Okay? I know this is weird, mostly probably because you're using a bunch of letters and because we're using R in a different way now. And L is like, oh, what's L? What's this L thing? Well, L is the slant height of the cone. So to solve for X, the area of this sector right here, Let's multiply both sides by pi l squared. So that'll cross out pi l squared over here, and we'll multiply it by this side here. So x equals 2 pi r over 2 pi l times pi l squared. While that looks really weird, let's go ahead and reduce some stuff. Some things can cancel out. 2 pi over 2 pi cancels out. That's 1. So we get rid of those. So now we have r over l times pi l squared. So let's say x is now r times pi. Now l squared is l times l. I'm just going to make sure, in case you haven't done algebra in a while, I'm going to do it like that. All over l. So we have two l's here, one l right here, so I can cancel out one set of them. Okay, and what are we left with? We're left with r times pi times l. Because we like to do constants first, I'm going to put pi first. So x is pi times r times l. Okay, where x is the area of your sector, the area of this party hat. Now this party hat happens to be the lateral area of the cone. Okay, in fact, I'm probably going to add a page. Well, no, I'm not going to add a page as I do this. But we just found the lateral area. I should have put LA. So LA equals pi RL. This is LA of a cone. Okay? I know that was a lot of work there. You're going to have to rewind this a couple times if you're going to have to get it, because my reinforcement will take way too long to say, okay, let's do it again. Okay, let's do it again, etc., etc. I have to make sure that you kind of get it in one swoop, and if you don't, you keep rewinding to see how we got to this point. Or just remember this, pi RL. But that's lateral area. It's not surface area of an entire cone. Now, for the party hat, that's the entire surface area, because a cone does not have a bottom. It just has an opening, right? That's where you fit your head. Cones in practice, well, actually, maybe. This all depends. But cones in practice might have a bottom. So we're going to sometimes use a bottom with the cone, and sometimes we won't. I guess it does depend on the problem. We're going to look at a problem that has an ice cream cone. And an ice cream cone does not have anything there. It's just a hole, right? So we're going to have to just look at the cone itself. But if we took this part, remember when we did cylinders, and because I'm going to talk about cylinders when we talk about volume here, but when we did cylinders, we unfold the toilet paper, and then we get a rectangle, and then a circle on top and circle on bottom. Sorry that you can't really see it, but check that out. Rectangle for the lateral area. The whole surface area also includes my two bases on top and bottom. So when we do this cone right here, there's the lateral facing, this stuff right here, and then there's the bottom. So if we were to unfold the entire thing with a base bottom, it would have this portion right here. Let me make this all one color, all one red. It would be this portion right here, plus the bottom, which is a circle. Okay? So this would be a part of your net. If you were to draw an entire net, it would be this red plus this red. And this red has remember, it has a radius of r. So this is where the r comes in. If you look again, here's radius of r. This is that circle. This is where you look at that r right there. It has nothing to do with this thing right here. This has nothing to do with r. Remember, this has to do with L. But when you take whole surface area, lateral area was pi RL, which was this part right here, lateral area. Surface area also includes the area of this circle. The area of this circle, the area of your base, is pi r squared, where r actually is your radius. So your surface area, whole thing, is pi r squared plus pi RL. It's your area of your base plus lateral area. That's the surface area of a cone. Okay. Again, I'm going to sit here for a second so you can kind of process everything we just did here. Remember, surface area is area of the unfolded thing. We make this net, we unfold it. This is what the area of this plus the area of that. So that's all I did. It's just understanding where pi RL comes from. Okay, but I'm going to move on for the sake of time. Now you can actually look at these things as a whole. So this is end number 18, surface area and volume of a cone. Okay? So again, you see a cone here has a slant height of L. It has a base with a radius of R. This base here unfolds and it becomes, or well, it doesn't really unfold, but you unfold the cone and this base sits on the outside with a radius of R. Now this one looks a little different. Its sector, it looks a little bigger. Whereas when I actually unfolded this cone, I actually unfolded this party hat right here, and this is what I got. While their sector looks a little deeper like that. Okay. But either way, they're both cones. So the fact remains, this is still the sector of a circle. Okay, still the sector of a circle. Now I'll draw that again. The circumference of this entire circle, remember, is 2 pi L because your radius of this is an L, not an R. And yeah, by the way, this is an L. It's hard to see that cursive L on this, but these are L's. Circumference of the entire thing is 2 pi L. The circumference, or not the circumference, but the length, the arc length of this portion right here, remember, is the same as unfolding this bottom. So the circumference of your circle base. So this part is 2 pi R. That's when we take this out of the entire thing, which is 2 pi R over 2 pi L. So your surface area, again, is your lateral area plus your base area. Your base area was pi r squared. Your lateral area is pi rl. Doing what we did on the previous page. If you want to look at it again, remember the advantage of YouTube is that you can rewind and figure out how I did this part right here, from this step all the way down to this step. 1, 2, 3, and 4. So again, keep referring to that if you're stuck as to why this is the radius of, or why that's the circumference of the circle of your base, etc. Okay, so there's surface area. Once again, writing it one more time. Whoops. Okay, so those are those two things right here. Now let's do some examples using what we know. So let's take surface area and go down here. So example, you have a cone right here. It has a base. Now this is an upside down cone. Think more like an ice cream cone or like a snow cone. Okay, surface area of a cone in general equals pi RL plus pi R squared. Area, lateral area plus area of base. Or you could just say, once again, LA plus B, and then you say LA equals pi RL, etc., etc., etc. You keep working. Okay, your slant height is 6 inches. Remember, this guy right here is your slant height all the way around. These are all slant height. They're all the same. Your radius of your circle is 4. Simple enough. The rest is kind of substitution here. Well, it's very much substitution. Surface area is pi times 4 times 6. Pi times radius times slant height plus pi times 4 squared. So your surface area is 24 pi plus 16 pi, which is 40 pi square inches. Now I do believe that this actually asked me to, no, it didn't ask me to round 2 decimal places. Oh, down here it does. So this is rounded 2 decimal places later, so you can multiply that by pi and do that. But again, if you were to draw a net for this thing, let me go ahead and I'm just going to move it to the side over here. Oops. Okay, well maybe I won't move this to the side. Okay, this isn't working. I'm just going to delete this and I'll get it later. If you were to draw a net for this thing, you want to do something where it looks like you unfold the party hat portion like that. Okay, this is your slant height, 6. This is also 6, so is everywhere around. This distance is the radius of your base of your circle right there. So if you want to write what that distance is, it would be 2 pi times 4, which is 8 pi. If you need that, but here's the other portion you need. There, the base with a radius of 4. So here's your net. It looks a little different from our other nets when we unfolded and made rectangles, right? So that looks a little different. So look at that again for 5 more seconds. I'm going to go back and put in the other work. But that's what the net looks like. Okay. Do a couple more examples here. Find surface area of the following cones. Use the pi button around 2 decimal places. Same thing. Lateral, or not lateral area. Slant height is 12. radius is 10. Okay. Your surface area, here, this time I'll break it up. I'll put lateral area plus area of base. Your lateral area is pi RL. Your area of base is pi r squared. So your lateral area is pi times 10 times 12. Area of your base is pi times 10 squared. So lateral area, 10 times 12 is 120. 120 pi, area of base, 10 squared is 100, so you have 100 pi. So surface area is lateral area plus area of base is 220 pi square inches, or 220 times pi, using my calculator, 691, rounding to 2 decimal places, 691.15 square inches. Okay, one more time, and this one's a little bit different because now you have the height of the cone. Remember, height of the cone goes perpendicularly down. Slant height is over here, this guy. So if we took out a cross-section of this cone, we're just looking at a right triangle here. And they actually give you a hint on this. Use Pythagorean theorem to find L. Well, I can do you one better. I know this is a 3, 4, 5 special triangle. But even so, to make sure you guys totally get it, let's say 3 squared plus 4 squared equals L squared. So 9 plus 16 equals L squared. L squared equals 25. L equals 5. Okay, so I'm going to go ahead and erase all that again because I want to make sure I have room. But L is 5. That's your slant height. 5. The radius of your base is 3. These are centimeters, by the way. Your surface area is lateral area plus area of base. Lateral area is pi RL. Area of base is pi r squared. Lateral area is pi times 3 times slant height, 5. Be careful, it's not this height, it's not 4. Area of base is pi times 3 squared. 3 times 5 is 15 pi. I'm sort of sounding a robot here. And base is 9 pi. Surface area is 15 pi plus 9 pi, which is 24 pi square centimeters, or 24 times pi equals 75.398, 79.40 square centimeters. Okay. All good? So that's surface area. As far as formula and stuff, I suppose it's pretty simple. But this understanding takes a little bit of time. Now, it's necessary to know, though. I do want you to know how this works, especially when it comes to drawing a net. I want to make sure that you understand what this distance represents when you draw the net, how this distance works out, and how we got to this understanding. I really, really, really would like you to understand that. Okay, that's all surface area. Let's go to volume. And we did volume together because we did that Mars task on glasses, but I just want to redo it so we have it officially written in notes somewhere. The volume of a cone is equivalent. I'll put equivalent. The volume of a cone is equivalent to the volume of a cylinder. Maybe the word similar. Let's use similar because it's not equivalent to. It's similar to the volume of a cylinder in the same way that the volume of a pyramid is related. Oh, I'm sorry. The word must be related. Sorry, this is my first time looking at this. Is related to the volume of a prism. So we talked about this. I did notes before where we looked at a prism right here, and it has some base, and let's say it's a square base like this. Now if you draw a pyramid inside of it, oh, hang on a second. Okay, now if you draw a pyramid inside of it, okay, and it goes up like that and down like that, whatever, and it has the same height and base and everything else, the volume of this prism would be base times height. The volume of the pyramid, prism, volume of pyramid equals 1/3 that. Okay? Reasons why kind of unknown here, but cone and cylinder are the same way. If I draw a cone inside the cylinder with the same height of h, and it has the same circular base, the volume of this cone is exactly 1/3 the volume of the cylinder. So the volume of one cone plus the volume of the same cone plus the volume of the same cone, 3 of these guys, 3 cones equals 1 cylinder with same base and height. Right? Area of base and height are the same in both of these. You get the same volume. Now, I did examples before, but I'll just keep working with you on this. Make sure you get it. So the volume. Okay, so all right. So here, so let's first look at a cylinder. Be careful not to write in this area because I'm going to erase this. The volume of a cylinder is still area of base times height, but specifically in a cylinder, the area of your base is the area of a circle. So your base is pi r squared, if your radiuses are here. So the volume of a cylinder equals pi r squared times height. So you can leave it like that if you need to, because again, when you saw your the glasses Mars task, you saw it. So the volume of a cone with the same base and height is 1/3 that volume. So 1/3 pi r squared times height. So I'm going to be using this formula here to help you out. 1/3 pi r squared times h. If you don't want to see it that way, just say 1/3 area of base times height. Volume cylinder is area of base times height. Volume of cone is 1/3 area of base times height. Just like it is for prism and pyramid. Area base times height, 1/3 area base times height. The only difference is now we're looking at a circular base and not like a polygon base. Okay, so let me do this example. I'm looking at a... I can't ever remove that. I'm looking at a cone with a circular base with a radius of 8. So my r is 8. My height is 12 centimeters. Okay, and let's go ahead and find the volume of this cone. So the volume is 1/3 the area of my base. Okay, there's area of base right there, pi r squared, times height. I'm doing it all in one motion here. Okay, 1/3 of 12 is 4. 8 squared is 64. 64 times 4 is 256. So I get 256 pi cubic centimeters. Okay, that's pi. Okay? So, skipping some of the math there. You can use your calculator for that as you go. Okay, find the volume of the following cones. Okay, same thing. Volume of cone is 1/3 area of base, pi 5 squared. There's area of base times height, which is 9. Excuse me. 1/3 of 9 is 3. 5 squared is 25. 25 times 3 is 75 pi cubic centimeters. And again, if I'm rushing through some of the math, please stop me at some point as we do this. Okay, again, we need height. For this one, we need height, and we also need radius. Okay, so we're going to need this value, and we're going to need this value right here. Radius is pretty simple. It's half of 20. If 20 is your diameter, 10 is your radius. Now I'm looking at something here where I have 26, h, and 10. This is a right triangle. I can use Pythagorean theorem to solve for h. That's 10 squared plus h squared equals 26 squared. Okay, that's your setup. I'm gonna save time as far as solving for that because I can see that this is a 5, 12, 13 special triangle. So if everything was multiplied by 2, this is 10, 26. This is 24. So I know that myself. You might have to know that yourself or use Pythagorean theorem, but I know h will be 24. Don't take my word for it. Do it yourself. See what you get, but you get 24 meters for h. And by the way, our radius was 10. So volume. Oh, I didn't even see these things down here. 75 pi. Oh, you know what? They want you to round on this. Let's go ahead and do that. 75 times pi. Sorry, I'm going back for a problem for a second. 235 0.62 cubic centimeters for that volume. This volume is 1/3 the area of my base times height. 1/3 of 24 is 8. 10 squared is 100. 100 times 8 is 800. So you get 800 pi cubic meters. 800 times pi is 2,513.27 cubic meters. Okay, now that's good practice for you. We got a lot of things. Oh, I have one more. We got a lot of things done. Now here's one with the ice cream cone thing I was talking about before. Okay, the math club has decided. Now I have like 5 minutes to do this one, so I'm going to work quickly. Math club has decided to sell giant waffle ice cream cones at the spring fair. Jacob bought the cone, but then he got distracted. When he returned to the cone, the ice cream had melted, filling the cone to the very top. So pretend like you had an ice cream cone right here, and it's like, oh yeah, we got ice cream. But then eventually this ice cream all melts down, and all that's left, all that we're looking at now, is here, where there's ice cream inside, but it's only flat at the very top right there. So that's what this problem looks like. It melted. Here's what we have. It says if the diameter of the base of the cone is 4 inches, so if this thing is all 4 inches, okay, and by the way, I'm going to take out that 4 right now and just say the radius is 2. So the radius is 2 inches, and the slant height is 6 inches. So this guy right here is 6. We need to find the volume of the ice cream, how much ice cream's inside, and the area of the waffle that made the cone. Let's do volume first because we were just working on that. I need to find out what this height is right here. I have 2 and 6 here, so I need to use Pythagorean theorem. Now this is not a special triangle. So I have 2 squared plus h squared equals 6 squared. So h squared equals, 6 squared is 36 minus 2 squared, which is 4, so it's 32. Again, I'm running out of time here. So h is root 4, there's 2 root 4. 4 root 2, I think, is 4 root 2 inches. Okay? Oh, r, by the way, is 2. And slant height, L, which we're going to need, is 6. Okay? Let me try and move this to the side one more time because it's annoying. There we go. Yay, I moved it. Okay, so our volume is 1/3 area of base, pi r squared, times height, which is 4 root 2. Okay, I can't do 1/3 of all this very well. So volume is, so 4 pi times 4 root 2 is 16 pi root 2. This is all divided by 3. I'm going to use the calculator for this one because that exact answer does not look that great. Times pi times square root of 2 divided by 3, and I get volume is 23.70 square inches of ice cream, or cubic inches of ice cream. Dang, that's a lot of ice cream. Okay, surface area. Surface area, remember, when we did surface area before, and I talked about that pi RL stuff, like this stuff right here, it was lateral area times area base because we had something in the base. But this time we're looking at a cone, and a cone is hollow, right? It goes through, so we're not going to have a base here. So before, when we did this stuff, I only want to look at the unmapped party hat. I don't want to look at this thing here because this has nothing to do with an ice cream cone. Okay, people might be coming in soon. So I just want to get lateral area, which is pi RL, not surface area. That's pi times 2 times L, slant height, which was 6, which is 12 pi, which is 37.70 square inches. Okay, now I've run out of time. People are about to come in. Hope all this made sense. This was N number 18. Have a good day.